Alright, so today we're going to start talking about elastic and inelastic collisions in two dimensions. And we're going to look at both of these types of collisions, but when we talk about things in two dimensions, that means we're looking at them moving in both the x and the y direction. So we have to go back to using vector components, breaking things down into x and to y, and solving things separately in the x and the y direction, and then bringing them back together to have a resultant velocity. Okay, so let's go ahead and pause the video and get the problem written down, and we'll get started here in just a second. Alright, so what we see here is a puck that's moving east. It has a mass of 0.5 kilograms. It's moving east at 2.4 meters per second. It's going to collide with a 0.3 kilogram puck that's initially at rest. Okay, after the collision, the first puck moves 1.8 meters per second at 30 degrees north of east. Okay, which means we're going to start moving basically out like this. 30 degrees, 1.8 meters per second. And then we're going to find the speed and the angle of the second puck. So we're looking essentially for which variable? We're looking for v sub 2 prime. That's going to be what we're trying to solve for. V sub 2 prime. Remember, prime means after collision or post collision. Okay. However, we can't start solving this problem yet because we've got velocities in the x direction and in the y direction. Okay, our initial velocity is in the x direction, but as our final velocity, or our v sub 1 prime, has both an x component and a y component. So we need to start solving these in terms of horizontal momentum and vertical momentum. Okay, remember that in an elastic collision or in an inelastic collision, both of these types have conservation of momentum, which means momentum remains throughout the duration of the collision, right? Momentum is conserved, so nothing is lost. So we have to start solving these momentum problems now in two dimensions. So I'm going to kind of show you how I organize these problems, and you can choose a different way that works better for you if you want, that's fine. But I'm going to start kind of showing you how I look at organizing these types of problems. So first I'm going to list my variables. M sub 1 is our first puck, and it weighs 0.5 kilograms. V sub 1 happens to be moving east, okay, which means it's only in the x direction. So I'm going to have a 2.4 there. And I like to just draw an arrow to tell me kind of which direction it's moving. You can also indicate from there that v sub 1y is equal to 0. We can see that. Our second object now, m sub 2, has a mass of 0.3 kilograms. Our v sub 2 in the x direction is 0, and v sub 2 in the y direction is also 0 because it tells us this puck is at rest. It's not moving initially. Okay. From there we have a couple other things that we can use and we can solve for. We know the final velocity of our first object. We know that v sub 1 prime essentially, and v sub 1 prime is going to be the hypotenuse of that component triangle. Okay, so if I want to solve for v sub 1x prime and v sub 1y prime, that means I want to solve the components of this post-collision velocity. Okay, so let me redraw this triangle just a little bit nicer. We know that after our collision, our second puck is moving 30 degrees north of east at 1.8 meters per second. So this bottom side of that component triangle, this side right here, would be labeled v sub 1 x prime because it's the velocity of our first object in the x direction after the collision. This would be labeled v sub 1 y prime. Okay, so now we just use our sine, cosine, tangent, our trig functions to solve for that. v sub 1 x prime will take 1.8 times cosine of 30. Make sure that your calculator is in degrees and not radians. Okay, so that gives us a value of 1.55 meters per second. And since it's positive, we know we're going east, that's going to be left as a positive component. Okay, now we can solve for v sub 1 y prime, 1.8 times sine of 30, because v sub 1 y prime is opposite of that 30-degree angle, which gives us 0.90 meters per second. Okay, and that's going up, and this one's going to the right. So these little arrows kind of just give me a little bit better idea about what direction each of those is heading. We do not know v sub 2x prime or v sub 2 y prime. Those are going to be the components we're solving for in order for us to find our overall goal of v sub 2 prime. Okay, most likely this second puck's going to leave at some angle. It's going to bounce off at some angle after this collision. So we're going to have to find the x and the y components of that resultant triangle and build that new resultant. Okay, so now that we've got all of our variables, I'm going to show you kind of how I organize these problems. Alright, so I just gave myself a little more room here, and we're going to start looking at finding this second object's velocity. And the way we have to look at these is we're going to solve the momentum in the x direction and the momentum in the y direction. So this is kind of how I organize this. I'm going to start by solving momentum in the x direction. P sub x means momentum in the x direction. This little bracket means nothing, it's just helping me kind of keep things organized and let me know where the x direction is and where the y direction is. So this means I'm only looking at components in the x direction. Okay, let's look at our equation for an elastic collision. Momentum of an elastic collision is m1 times v1 plus m2 times v2 equals m1 v1 prime plus m2 v2 prime. But since we're only looking at momentum in the x direction, really we're only looking at v sub 2x, v sub 1x, v sub 1x prime, and v sub 2x prime. Okay, so that's an important distinction to be made here. So now we can start plugging in some numbers. Mass of our first object was 0.5. V sub 1x was 2.4 meters per second east. 2.4 meters per second. Since it was moving east, it's in the positive direction, so we can keep it at positive 2.4. Our second object had a mass of 0.3, but it started at rest. Okay, its v sub 2x was initially 0. M sub 1 again is 0.5. v1x prime we solved for and found it to be 1.55 meters per second to the east, so we don't have to make that a negative or anything like that. We're solving here for v sub 2x prime. Remember that our overall goal is to find out what v sub 2 prime equals. In order to do that, we have to find the x and the y components. We have to find the x and the y components of v sub 2 prime. So let's go ahead and do the math here that goes into this. The whole left side is going to equal 1.2. Plus 0.3 times v sub 2x prime. I'm going to subtract this over. And I get 1.1225 equals 0.3 v sub 2x prime. And then I'll divide by that 0.3, and v sub 2x prime is equal to 3.74 meters per second. And that came out a positive, so we assume it's going to the east. And I see a little mistake I made here, so I need to fix the math. I'm sorry. I was a little bit off by a decimal place. So This really gives us 0.775, which means 1.2 minus 0.775 leaves us with 0.425. Which means we really have a v sub 2x prime of 1.42. There we go. And it's going to the east. Alright, so we've got the v sub 2x component. That's not our final answer, but that's our v sub 2x component. We've got now the x component of our resultant. Now we need to solve for the y component. So I'm going to give myself some more room here to solve for y. Now we'll go ahead and start solving for momentum in the y direction. Okay, again, the bracket doesn't mean anything, it just kind of helps me keep my things organized. So now we'll start looking at momentum in the y direction. So that means we only use components of things in the y direction. Okay, our mass of a first object is 0.5. It has no initial velocity in the vertical direction, so we have a 0 there. Mass of our second object is 0.3, and it has no initial velocity at all, which means it also gets a 0. Now we're looking at post-collision. So post-collision, mass of the first object is still 0.5, and the velocity of that object post-collision is 0.9 meters per second. Second object has a mass of 0.3, and we're solving for v sub 2y prime. We're going to solve for the vertical component of that final velocity. Okay, so the whole left side here is a 0. Now I need to subtract over that 0.45, and I'll divide that by 0.3. Okay, which is going to give me a negative number. Okay, and it gives me a negative 1.5 meters per second. What direction does that tell me that my y component is going if it's negative? Okay, it tells me that it must be going down, in the downward direction. Okay, so now we know this is equal to v sub 2y prime, which means we have v sub 2y prime and v sub 2x prime. We're almost there. Once we have the components of our final vector, our last step is going to be to put those components together, add them tail to tip, and find that resultant vector. Okay, we add these vectors tail to tip and find our resultant vector. Alright, so I'm going to do that down here in the corner. Okay, so this is v sub 2 prime. My x component goes to the east at 1.42 meters per second. My y component goes to the south at 1.5 meters per second, which means my resultant, which goes from the origin to the tip of the last vector, must equal v sub 2 prime, and I want to find that angle as well. Okay, v sub 2 prime has to be a velocity vector, which means it must include both magnitude and direction. Alright, so the hypotenuse of that triangle, or our resultant vector, is 2.07 meters per second at, we want to find this angle here by using second tangent of opposite over adjacent. So here we're going to take second tangent of 1.5 divided by 1.42 to get our angle, which gives us 46.6 degrees. And this angle right here is touching the east axis, and we know it's south of east. Okay, so 2.07 meters per second at 46.6 degrees south of east. That's the velocity at which our second puck rebounds off of that particular collision. Alright, our next problem is still considered technically an elastic collision, so go ahead and read through the problem, get it written down, and then I'll kind of explain what's happening here, but it is still technically an elastic collision. So for this particular problem, we've got an object that begins as one and then separates into two parts. So that's the reason it's still considered an elastic collision, is because we're ending up with two separate parts rather than ending up with one part, which is what an inelastic collision is. So here we've got two objects at the post-collision, but only one object to begin. So you can think of it as one object to begin with, or you can still think of it as those two separate objects. Okay, but essentially what we have going on here is we've got a 7 kilogram object that's moving 12 meters per second east. It begins to split, or it splits into two different fragments. Here's our 5 kilogram fragment. It moves south after the collision, and then our 2 kilogram fragment has to move some other direction post-collision. We don't really know where it's going after our collision. Okay, after our collision, or the explosion here is technically our collision. So this is what we're solving for. We're solving for v sub 2 prime. Okay, we want to know the velocity and direction of our second fragment, which happens to be this 2 kilogram guy right here. Okay, so to think of this object, you can either think of it as a 5 kilogram object and a 2 kilogram object that are traveling at the same velocity to begin with, or you can simplify it and just make it one 7 kilogram object that splits into two different objects post-collision. That's totally up to you. Okay, but I'm going to go ahead and clear the screen off and get myself some more room so we can start this problem to solve for v sub 2 prime. Okay, so I'm going to go ahead and solve this problem with essentially two parts at the beginning that are both traveling with the same initial velocity. So my m sub 1 is going to be my 5 kilogram part. V sub 1 is still 12, and it's to the right, or to the east. M sub 2 is 2 kilograms, and V sub 2 is still 12 meters per second to the east. Okay, since we know those are both east directions, we can go ahead and put our subscript x in there, which means we know that V sub 1y initially is 0, and V sub 2y initially is also 0. Okay, post-collision, we know that V sub 1x prime is 0, and V sub 1y prime is 15 meters per second south, so we need to make sure to include that negative. Okay, it tells us that our 5 kilogram part is traveling 15 meters per second south, so our V sub 1y prime has to be negative. V sub 2x prime is what we're solving for, and V sub 2y prime is what we are solving for. Alright, so I'm going to go ahead and start solving these in the x and the y direction. Okay, remember the bracket doesn't mean anything mathematically or anything different, it's just about keeping organized. Okay, so m sub 1 is 5, m sub 2 is 2, they're both traveling 12 meters per second in the x direction east. M sub 1 is 5, and we know that V sub 1x prime is 0. We're solving for V sub 2x prime. Okay, so this is 60 plus 24 equals 2 V sub 2x prime. So 84 equals 2 V sub 2x prime, which means V sub 2x prime is equal to 42 meters per second. And it came out positive, which means we know it's traveling to the east as well. Alright, now let's look at momentum in the y direction. Both of our objects have no initial velocity in the y direction, so they're both going to get zeros here. Our first object moves 15 meters per second south, so we have to include that negative. And we're solving for V sub 2y prime. So this gives us negative 75 plus 2 V sub 2y prime. We're going to add that to the other side. Which means that V sub 2y prime is equal to positive 37.5. Which means it's going in the upward direction. Okay, now we've got each of our components. our v sub 2y component and our v sub 2x component of our second object post-collision. So I'm going to go ahead and start solving for my resultant here. I know my x component is 42 meters per second east. My y component is 37.5 meters per second north. So my resultant, or my v sub 2 y prime, I'm sorry, v sub 2 prime, is going to be the hypotenuse and that angle there. So go ahead and solve for that resultant. I added my two component vectors tail to tip. Again, we could have gone north and then east if we wanted to. It's going to still give us in the same final destination, but we want to find that answer using Pythagorean theorem and second tangent. Okay, so the resultant here of our second object comes out to be 56.3 meters per second at 42 degrees north of east. So that's the velocity of our second, or our explosive part that weighs 2 kilograms. Will be traveling that direction after the explosion. Now we'll go ahead and look at inelastic collisions in 2 dimension. Remember here that momentum is still conserved, so we still have momentum of the object initially is going to equal momentum of the object finally, or after that collision. Okay, so the only thing that changes here is the overall equation that we use. So I'll go ahead and get this problem written down and we'll get started on it. Okay, so for this particular problem we've got an object that weighs 900 kilograms and its initial velocity is 12 meters per second to the east. Okay, so it's only a horizontal velocity. We have a second object that weighs 600 kilograms and its initial velocity is 24 meters per second north. Okay, so let's go ahead and start looking at this equation for an inelastic collision. Remember that we're going to solve these in the x and the y direction, but I'm going to write just the inelastic collision equation up here so we remember what that looks like. Okay, we're still going to solve this in the x and the y directions, but this is the overall equation for an inelastic collision. These two objects hit and stick together, so after that collision they become one object. So let's go ahead and start with momentum in the x direction. My first object has a mass of 900 and a velocity of 12. My second object has a mass of 600 and a velocity of 0. This velocity is 0 because its initial velocity is only in the y direction. Okay, we're only looking at that now in the x. Okay, so now we're going to take the sum of those masses and we're going to solve for v sub x prime. Okay, we only have one object, so it's not v sub 1x or v sub 2x. It's just velocity in the x direction post-collision. Okay, so on the left side of our equation we've got 900 times 12 plus 0 equals 1500 times v sub x prime, which means vx prime is equal to 7.2 meters per second. And it's positive, so we know that it's traveling east. Let's look at momentum now in the y direction. Our first object has no velocity in the y direction. Our second object has all 24 meters per second in the y direction. And we're going to solve for v sub y prime. Okay, which gives us a v sub y prime equal to 9.6 meters per second up. Okay, or in the positive y direction, which is north. Okay, last but not least, we've got to find the overall velocity of these two objects. So I'm going to add my vectors tail to tip. Okay, my x component was 7.2, my y component was 9.6. and I want to find V prime and the angle. By using our Pythagorean theorem and second tangent, we get an answer equal to 12 meters per second at 53 degrees north of east. Alright, so this last problem I want you to go ahead and try to solve yourself. Okay, so go ahead and pause the video, get it written down, and solve it completely through. I will work just a few things here and give you a final answer, but make sure you pause the video and then go ahead and play it when you're ready to look at the answer and check.